Welcome to Galactic Secrets, where we delve into the minds that changed the course of human history and reshaped our understanding of the universe. In today's episode, we explore the incredible journey of Albert Einstein, one of the most influential figures in science, whose theories continue to define the way we see the world. From the theory of relativity to his discoveries that laid the groundwork for quantum mechanics, Einstein's work has permeated every corner of modern physics. In this documentary-style video, we explore not only Einstein's groundbreaking scientific contributions, but also his legacy in both scientific and popular culture. How did his work change the scientific landscape? And how does his influence still shape research today? Make sure to like, subscribe, and hit the notification bell to stay updated with our in-depth explorations of the cosmos and history's greatest minds. After this video, don't forget to check out our other episodes that dive into cosmic phenomena and the scientific wonders of the universe. Who was Albert Einstein? The man behind the genius, Albert Einstein's early life and academic journey. Albert Einstein was born on March 14, 1879, in the small town of Ulm, in the Kingdom of Württemberg in the German Empire. Raised in a secular Jewish family, Einstein's early life was marked by curiosity and a deep desire to understand how the world worked. The early spark of curiosity. At the age of 5, a simple compass given to him by his father ignited Einstein's lifelong interest in the invisible forces that govern the universe. This moment was pivotal, as Einstein would later describe it as the starting point of his intellectual journey. His curiosity about magnetism and his desire to know what lay beyond the visible world never faded, fueling his later works in physics. Struggles with conventional education. Einstein did not fit well into the rigid schooling system of his time, which he found stifling. In school, he was rebellious and often criticized for his unconventional thinking. His teachers did not always recognize his brilliance, and he even failed an entrance exam to the Swiss Federal Polytechnic at first. However, his passion for mathematics and physics drove him to pursue a teaching degree, and eventually, he became a professor. Struggles with finding a job. Despite his academic talents, Einstein struggled to find a teaching position after graduation. It was only in 1902 that he secured a job as a technical assistant at the Swiss Patent Office in Bern. This job, though seemingly unrelated to his field, gave him ample time to think about the mysteries of the universe and develop his ideas. It was during this period that he wrote the famous papers of 1905, a series of works that revolutionized physics forever. The 1905 Miracle Year, the birth of modern physics. The year 1905 is often referred to as Einstein's Annus Mirabilis, or Miracle Year. It was during this year that Einstein published 4 papers in the Annalen der Physik, each of which introduced revolutionary ideas that would transform science forever. These papers changed the trajectory of modern physics. The photoelectric effect, the birth of quantum theory. In his first paper, Einstein explained the photoelectric effect, the phenomenon where light striking a material causes it to emit electrons. Einstein proposed that light is not just a wave, but is also composed of particles, which he called quanta, now known as photons. This groundbreaking work helped establish the field of quantum mechanics and earned him the Nobel Prize in Physics in 1921. Special theory of relativity, a new understanding of space and time. Einstein's second paper introduced the special theory of relativity, which fundamentally altered our understanding of space, time, and energy. This theory proposed that the laws of physics are the same for all observers, no matter their state of motion. Perhaps the most famous equation derived from this theory is E = mc2, which shows that energy and mass are interchangeable. This formula has had profound implications in fields ranging from nuclear energy to modern particle physics. Brownian motion, proof of atomic theory. In a third groundbreaking paper, Einstein provided a theoretical explanation for Brownian motion, the random motion of particles suspended in a fluid. His work provided strong evidence for the existence of atoms and molecules, which was not widely accepted at the time, and gave the final push for atomic theory to be accepted by the scientific community. Relativity of simultaneity, a new perspective on time. Einstein's final 1905 paper dealt with the relativity of simultaneity. He showed that time is not absolute, and that different observers moving at different speeds would experience time in different ways. This was a precursor to his later work on general relativity, where he further explored the relationship between space and time. General theory of relativity. A masterpiece that redefined gravity in 1915, Einstein published his General Theory of Relativity, a work that fundamentally changed our understanding of gravity and the nature of the universe itself. A new perspective on gravity. Before Einstein, gravity was understood as a force, as described by Newton. However, Einstein proposed that gravity is not a force but the result of the curvature of space-time caused by mass. This concept led to the understanding that massive objects like stars and planets bend space-time around them, and this bending is what causes the sensation of gravity. The bending of light and the eclipse. Einstein's theory predicted that light would bend when passing near a massive object, like the sun, due to space-time curvature. In 1919, during a solar eclipse, scientists observed the bending of light from distant stars, providing experimental confirmation of Einstein's prediction. This was a groundbreaking moment that established Einstein as a household name and demonstrated the validity of his ideas to the wider public. The expanding universe and black holes' general relativity also laid the groundwork for many modern discoveries, including the understanding that the universe is expanding, the existence of black holes, and the possibility of gravitational waves. These concepts were largely theoretical when Einstein proposed them, but they have since been confirmed through modern observations. The speed of light, time dilation, and space-time. One of Einstein's most profound insights was the role of the speed of light as the cosmic speed limit. This principle, along with his ideas of time dilation and space-time, changed the way we view the fabric of reality itself. The cosmic speed limit. Einstein's theory of special relativity stated that the speed of light in a vacuum is constant and the same for all observers, no matter how fast they are moving. This contradicted centuries of Newtonian physics, where the speed of an object was thought to vary based on the observer's motion. Time dilation and the relativity of time. Einstein's equations also predicted that time is relative. It moves at different rates depending on how fast an object is moving. For example, time slows down for objects moving close to the speed of light, a phenomenon known as time dilation. This has been confirmed experimentally with high-speed particles and even with astronauts traveling at high speeds. Space-time continuum. Einstein's concept of space-time as a four-dimensional fabric that can be bent and curved by mass and energy is crucial to modern physics. This space-time continuum describes the interaction between the three dimensions of space and the dimension of time, blending them into a unified framework that governs the universe. Einstein's legacy. Beyond science, Albert Einstein's contributions to science were monumental, but his legacy extends far beyond the laboratory. Political and social activism. Einstein was also a strong advocate for peace, civil rights, and social justice. A committed pacifist, he denounced the use of nuclear weapons after World War II, although he famously signed a letter to President Roosevelt urging the development of atomic weapons during the war. His views on politics were deeply influenced by his belief in human rights and the need for a peaceful world order. Philosophy of science. Einstein's reflections on the nature of science were equally profound. He famously said, "Science is a wonderful thing if one does not have to earn one's living at it." His approach was one of skepticism and humility, and he often debated philosophical questions surrounding the nature of reality and the limits of human knowledge. Modern applications and technologies. Einstein's theories continue to influence modern technologies such as GPS, nuclear power, and even space travel. The accuracy of GPS systems, for example, relies on adjustments for time dilation effects predicted by Einstein's theory of relativity. His work also set the stage for cutting-edge research into quantum computing, gravitational waves, and dark matter. Conclusion. Einstein's enduring impact. Albert Einstein remains one of the most influential scientists in history. His theories have not only transformed the landscape of physics, but have also changed the way humanity views the universe. From his work on special and general relativity, to his philosophical contributions and his tireless advocacy for peace, Einstein's legacy continues to inspire new generations of thinkers and researchers. If you enjoyed learning about this scientific genius and his groundbreaking work, don't forget to like, subscribe, and hit the notification bell for more deep dives into the universe's mysteries and the brilliant minds behind the most transformative ideas. Share this video with your friends and family to spread the wonders of the cosmos and humanity's journey to understanding it. Stay curious, stay inspired, and keep exploring the secrets of the universe.